Hello everyone, this is Coder2J. In today's video, we're going to dive into an essential topic, creating data frames from various data sources like CSV, JSON, and Parquet. Let's get started. In the first step, we need to set up our environment to work with Spark and create a Spark session as usual. Reading CSV files into DataFrame. Now, let's start by working with CSV files. CSV stands for comma-separated values, which is a common format for tabular data. We'll begin with a simple example of a single-line CSV file. We'll use a bash command to display the first 10 rows of this CSV file. This file contains information about products, such as their ID, name, category, quantity, and price. After that, we'll read the CSV file into a data frame. We define the path to the CSV file and use the spark.read.csv method to read it into a data frame, making sure to set the header option to true as the first row of our CSV file is the header. We can display the schema and first 5 rows of this data frame with the functions print schema and show. The schema helps us understand the data types of each column. We found the type of columns are all string, which is obviously not correct. Let's fix it by providing it with the explicit schema since we know what the data type of the column should be. We'll define a schema using the struct type and struct field classes from the PySpark.SQL.types module. Also, we need 3 schema types: string type, integer type, and double type. Every column type is defined by a struct field with a column name, data type, and if it is nullable. Here, the ID and quantity are integer type, name and category are string type, and price is double type. Then, we'll read the CSV file into a data frame using this explicit schema by passing the defined schema to the spark.read.csv function parameter schema and display its schema and content. Now, the schema of the data frame is correct. What can make the schema definition easier is the infer schema. It is a convenient option that allows Spark to automatically guess the data types of columns. It can save us from manually defining schemas. What needs to do is to set the infer schema option of the spark.read.csv function to true. And boom! Spark automatically finds the correct schema for us. Reading JSON files into DataFrame. Moving on to JSON files, which are a popular data format for semi-structured data. It stands for JavaScript Object Notation and is used to store data in a human-readable format. We'll start with a simple example of a single-line JSON file. Let's check the first 10 rows of this JSON file using the bash command. We can see every row is a valid JSON record for single-line JSON. To read it into a data frame, we can simply use the spark.read.json method with the path of the JSON file. As always, we'll show the schema and content of the data frame. We can see the proper schema is automatically set. Reading multi-line JSON files. JSON files can also have each record with multiple lines. We'll show how to handle such multi-line JSON files. From the bash command result, we can see a JSON record is defined in multiple lines. To read it into a data frame, we need to set the multi-line option to true. Once again, we'll display the schema and content of the data frame. The schema is also correct. Reading and writing Parquet files. Finally, we'll explore Parquet files, which is a columnar storage format that's highly optimized for analytics workloads. We'll write the data frame we've been working with into a Parquet file. To achieve that, we can just call the method df.write.parquet with the output Parquet file path. Let's refresh the data folder. We can see the data frame has been saved as a Parquet file. Now, reading this Parquet file back into a data frame is also super simple. Just use the method spark.read.parquet with the path of the Parquet file. After displaying its schema and content, we are sure it has been read successfully. And as always, it is recommended to stop the Spark session when finished the Spark tasks. That wraps up our journey through creating data frames from various data sources using PySpark. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell. Thanks for watching, and see you in the next video.